Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of limits. So as per the problem, use the graph to find the limit if it exists. And in part A, we have to find the limit as x approaches 2 for the function f at x. And here f at x is given in the form of this graph, which is this straight line. Now in this case we have to calculate the limit. Now the limit for a function exists at an x value if the left hand limit is equal to the right hand limit at that x value. So let's analyze the behavior of this graph at x equals 2 because that's where we have to find the limit. Now we have to make sure that the left hand limit is equal to the right hand limit. So as we approach x equals 2 from the left side on this graph, the function value or the y value approaches positive 2. So for evaluating limit, we are not looking for an exact point. We are analyzing the behavior of the graph as we approach the x value of 2. So from the left side, as we approach x equals 2, the y value approaches positive 2. And as we approach x equals 2 from the right side, again the graph approaches y equals 2. So that means the limit for this function as x approaches 2 is equal to 2 because that's the left hand and the right hand limit, and since they both equal the same value, that's the limit value for this function at x approaches 2. So now we can analyze part B. So in part B, we again have to evaluate limit x approaches 2 for f at x, and we are given the graph of this function f at x. So we have to check the left hand and the right hand limit, and if they equal, that means that's the limit value at that x value. So at x equals 2, now in this graph, there is an empty dot or empty circle at x equals 2. That means the function value does not lie on this graph. But as I mentioned earlier, for evaluating limits, we are analyzing the behavior of the graph. At that x value, we are not looking for a specific point. So let's start with the left hand limit at x equals 2. So as we approach x equals 2 from the left side along the graph, the y value approaches 1. And as we approach x equals 2 from the right side along the graph, so again the y value approaches 1. So that means the left hand limit is equal to 1, the right hand limit is equal to 1. So that's why the limit value at x equals 2 for this function is equal to 1, because that's the value of the left hand and the right hand limit. So in this case and in part A, the limits exist because the left hand limit is equal to the right hand limit. So now we can analyze part C. So in part C, we have to find limit x approaches 3 for function f at x. And in this case, the graph of the function is broken up into two parts. So there are these two horizontal lines. So there's the first one and there's the second one. And the graph breaks up at x equals 3. So first we'll have to evaluate the left hand limit and then the right hand limit and see if they equal each other. So as we approach x equals 3 from the left side, now for the left hand limit we have to use this lower horizontal line because the upper one doesn't exist to the left side of 3. So as we approach x equals 3 from the left side, the y value is equal to -1 because in this graph the scale on the y-axis is 2 squares is equal to -1. So as we approach 3 from the left side, all points have a y value of -1 because it's a horizontal line. So the left hand limit at x approaches 3 is -1. Now the right hand limit can be analyzed using the other horizontal line because this lower line doesn't exist to the right side of 3. So as we approach x equals 3 from the right side, so the y value approaches 1. So in this case, the left hand limit is -1 and the right hand limit is 1. So therefore the left hand limit is not equal to the right hand limit. So we conclude that the limit does not exist, or dne does not exist. So in this case, we cannot write a value for this limit. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.